In this video, we're going to be talking about how to add and subtract surds. In order to add or subtract surds, we must have like terms. So why is that important? So recall in algebra, right? We have like terms that can be added or subtracted. We cannot add or subtract unlike terms. So for example, if you have 2x plus 3x, that would give you 5x. Whereas if you have 2x plus 3x squared, well, those are unlike terms, so you cannot really add or subtract them. In the same way, if you have a surd like 2 root 2, and it's adding to 3 root 2, that would give you 5 root 2. Whereas if you have 2 root 2 adding to 3 root 3, well, those are unlike terms, so these cannot be added. Now, the other note says, sometimes you may have to simplify individual terms first to get like terms. All right, so now to the example. Simplify root 12 plus 2 root 27. Remember, the first step towards simplification is to find the largest square number, largest perfect square number that goes into the number under the root. So the largest square number that goes into 12 is 4. And 12 is 4 times 3. So I can write root 12 as root 4 times root 3. And then we have a 2. Then root 27 is root 9 times root 3. So we get 2 root 3 plus 2 times 3 times root 3. Right? So 2 and root 9 is 3. Then we have a root 3. So we get 2 root 3 plus 2 times 3 is 6, so 6 root 3. A lot of people will multiply the numbers outside the surd with the number inside the surd. This is wrong. It's like you have 6x, right? So you have to treat it just like you treat your algebra or your variables. So now you have 2 root 3 and 6 root 3 adding up. These are like terms. Why? Because they both have a root 3 next to them, or they both have a root 3 in them. So 2 root 3 plus 6 root 3 is 8 root 3. Just like 2x plus 6x is 8x. All right, now let's learn how to expand surds. So to expand surds, we use a method for expanding algebraic expressions. So just like you would expand the expression, for example, 2x plus 1 times x minus 3, right? You multiply 2x with x, then 2x with minus 3, then 1 with x, and then 1 with minus 3. Then you add the like terms, okay, and write your final answer. We do the same thing here with surds. So let's see how to do that. Okay, so 1 and 2, these are the first terms in my expressions, right? In each bracket. So 1 times 2 is 2. Then we have 1 times root 8. Well, minus root 8, so that's minus root 8. 1 times minus root 8 is minus root 8. Then we have plus root 3 times 2, which is plus 2 root 3. And then root 3 times negative root 8 is negative root 24. And this is actually using the law of multiplication of surds. So we have root 3 timesing with root 8, right? And you can bring both of them into one bracket. That was the law that we learned earlier, right? So if you have root 8 times root b, that would be equal to root of a times b. Okay, so root of 3 times 8 is root of 24, which is, well, if you, well, we're going to do that here, right? So 2 minus, and then root 8 is 2 root 2, right? We've seen this enough times, so we should be able to find root 8 directly. Root 8 is root 4 times root 2, so root 4 is 2. Then we have a 2 root 3 and root 24. Well, root 24 is root 4 times root 6. So 4 is the largest perfect square number that goes into 24, so we have root 4 and root 6. All right, now we have 2 minus 2 root 2 plus 2 root 3 minus 2 root 6. And since we do not see any like terms, because that would have been the next step, right? Collecting the like terms and adding or subtracting them. But since we do not have any like terms, why do we not have any like terms? Because root 2, root 3, and root 6 are like x, y, z, which are unlike terms. All right, so let's do some more examples. In this example, we have 2 plus root 5 timesing with 1 minus root 5. So 2 times 1 would be 2. 2 times negative root 5 would be negative 2 root 5. Then plus root 5 times 1 would be root 5. Then root 5 times negative root 5 would be negative 5. Okay, so notice what happened here. So the last one was root 5. Okay, and so I'll ignore the minus because I already put it here. So I'm just going to do root 5 times root 5. So let's see, why is that 5? Well, if you remember, one of the laws of multiplication of surds was if you have root a times root a, that is equal to a. Okay, so root 5 times root 5 is 5. Okay, so now we need to collect the like terms. So the first pair of like terms would be 2 and minus 5. So 2 minus 5. And then we have minus 2 root 5 and plus root 5. So minus 2 root 5 plus root 5. All right, so 2 minus 5 is minus 3. And minus 2 root 5 plus root 5. So now this is like minus 2x plus x. Okay, and by default, you can put a 1 here, right? So minus 2x plus 1x is minus 1x or minus x. So minus 2 root 5 plus root 5 would be minus root 5. So the final answer is minus 3 minus root 5. All right, let's do one more example. So this is 2 plus root 3 times 2 minus root 3. Okay, so if you notice the pattern, right, we can treat this like a plus b and a minus b, right? So a plus b times a minus b, we already know that that's equal to a squared minus b squared. That's the difference of squares. So difference of squares, or difference of two squares. So in this case, we have a, which is 2. So the answer would have a squared minus b squared. So a is 2. So a squared would be 2 squared. Then minus b squared would be root 3 squared. Root 3 squared. Now 2 squared is 4 minus root 3 squared means root 3 times root 3, which is 3. Or you can think of it like square cancels the square root, so you're left with 3, right? Just like plus and minus are opposites, times and divide are opposite, square and square root are also opposite. So you can actually cancel them. So 4 minus 3 is equal to 1. All right, let's do one final example of expanding surds. So we have 3 plus root 5 all squared. And we have to write it in the form a plus b root 5, where a and b are integers. A lot of people would start thinking about what this is, why do we have this, right, and so on. But don't overthink about this. Just start expanding this, right? If you expand this, maybe you'll get to this form, right? So 3 plus root 5 squared. Now, because there's a square there, that means we can write 3 plus root 5 twice. Okay, now we'll expand it just like the previous two questions. 3 times 3 is 9. 3 times root 5 is 3 root 5. Root 5 times 3 is again 3 root 5. Okay, so I'm not writing root 5 first and 3 after, because if you have an x, remember, surds are treated like variables. So if you have an x timesing with 3, it wouldn't be x3, it would be 3x. So that's the reason why I put 3 first. Then root 5 times root 5, well, root a times root a is a, so root 5 times root 5 is 5. So we have a plus 5 in the end. 9 plus 5 is 14, right? So we're adding like terms. 3 root 5 plus 3 root 5. Well, 3x plus 3x is 6x. So 3 root 5 plus 3 root 5 should be 6 root 5. All right, so now if you look at this form, we've actually got it already, right? So A is 14, B is 6. And A and B are supposed to be integers, which is what we have. So 14 plus 6 root 5 is your final answer.